Hello everyone. In this video I'm going to be going over how to solve rational equations. Those are equations that have variables in the denominator. So in this case, I'm looking at a rational equation that has expressions y minus 4, y plus 1, and y squared minus 3y minus 4 in the denominators. For problems like this, when I'm solving, as opposed to just adding the fractions or the rational expressions together, I want to get rid of my denominators. And the best way to do that is to first of all find our least common denominator. To do that, I want to make sure all my denominators are in their factored form, or as much as I can. And my first two denominators, I can't factor anything out, so I'll leave them as is. My third denominator I can factor into the binomial y minus 4 and y plus 1. From this, I can determine that my least common denominator for my whole expression is those same factors, y minus 4 and y plus 1. Once we have this, the most effective way of getting rid of our denominators is to multiply through so that they will eventually cancel out. Now to make that simple, what we can do is this. We can look at each of our denominators and determine what is it missing in relation to the LCD. So looking at our first denominator, y minus 4. When you compare it to the least common denominator, the term that it's missing is the y plus 1. So I'll take my numerator from that expression and multiply it times that missing term. And I'll put it down here, 3 times y plus 1. Looking at my second denominator, y plus 1, when I compare it to my LCD, it's missing the y minus 4. So I take my numerator, there's my subtraction sign from up here, and I say 2 times that missing term, which is y minus 4, equals. Looking at my last denominator, and I'll specifically look at this factored form because they are the same thing. So looking at my factored form instead, when I compare that to the least common denominator, it's the same thing, so it's not missing anything. In that case, I'll just take my numerator as is. So from that, I have this new equation that I will use to solve the problem. 3 times the quantity y plus 1 minus 2 times the quantity y minus 4 equals 5. Now I'll solve based on what's given to me. In this case, I'll start by distributing my 3 and 2. So I'll have 3y plus 3 minus 2y plus 8 as I'm distributing the negative 2 to the y and to the negative 4 equals 5. Now when I combine my like terms, the 3y and negative 2y end up being a positive 1y. The 3 and 8, both positive, add up to 11, and then my 5 is still 5. So 3y minus 2y becomes 1y, 3 plus 8 becomes 11, and 5 is 5. I'll continue to solve my equation by subtracting 11 from each side. And I'll end up with y equals a negative 6. So I've determined that y is equal to negative 6. Now lastly, with these kinds of problems, I need to check my answer. Now with an equation, you can always check your answer by putting the value for the variable back into the original equation. Specifically with this kind of problem, I want to in particular at least check to see that this value for y doesn't conflict with a domain, meaning that if I take this y of negative 6 And if I were to put it back into the y's here, here, and then over here in my factored form, if I were to put them back in, what I get is 0. So in other words, if I took a negative 6 and put it in for, and let me rewrite what I have so I don't have to keep, so I don't write too much on that area so as to be confusing. So here's the expression again, and I'm going to put the third denominator in factored form because that's how we want to think about it now. So what I'm saying is, now that I have a value, I want to determine if I put negative 6 in for y here, would the resulting value be 0? So in other words, negative 6 minus 4, is that 0? And no, it's not. So that's fine. If I put negative 6 in for y here, negative 6 plus 1, is that 0? It's not, so that's fine. And the same goes here. Same number, so it works the same way. If I put negative 6 in here, negative 6 here, neither one of those values would end up being 0. So what that means is that the negative 6 checks out. It will be a valid answer. If in fact I put negative 6 into a denominator and I got 0, then we would exclude that particular number. So this is how you approach a rational equation problem. I hope this was informative.